Okay, AP Chemistry, just a quick video on what to do with natural log and how to use e to the x. Now, quick thing, the inverse of natural log of x is e to the x. So I'm going to keep that as a fact or a side note up here. So let's say I have natural log of 0.228 per second over k1 equals 9.35, and I want to solve for k1. How do I do this? Well, my k1 is trapped in this natural log expression, and I have to figure out how can I get rid of this natural log expression. So going back to this inverse thing, remember, if I want to isolate something, I got to do the opposite of what's happening to it in order to isolate it. So if I have e raised to the natural log of x, this is just equal to x. That is because the opposite of natural log is e. So I'm going to take this whole expression and raise it with a base of e, and whatever I do to the left side, I have to do it to the right side. So e to the x, both of them. So I'll do e to the natural log of 0.228 per seconds over k1 equals e to 9.35. And remember what I said. E raised to the natural log of something, right? So e natural log of x is just x. E natural log of 0.228 per second over k1 is just going to be equal to 0.228 per second over k1 equals, now e to the 9.35 I could easily do on the calculator. E second e raised to the 9.35. So if I do it on the calculator, I'll get this huge number, 11498.82. Right? I may be using some real numbers that you would be using, right? So now I'll just plug this into the, so I could do calculator. E to the number, this is just a number. Okay? Remember, e is a number, I think it's like 2.7, so if I do second e raised to the first, it's 2.718. E is 2.718. That's just a number. And so this is just an exponential. And you don't have to have base e. Like you could have done exponentials in algebra or math class where you had 5 to the x or 9 raised to the x, right? And x is your value. Instead of having 5 or 9, we're going to use e. And the opposite of e is natural log and vice versa. And so now, once I plug in that e to the x, or e to natural log of 0.228 over k1, I'm just left with this. I cancel out e and natural log. And so now, this is just algebra to solve. I could switch k1 and 11498.82, or, I multiply by k1 and then divide by that. 0.228 per second over 11498.82 equals k1. And if I just plug this into the calculator, I will get 1.98 times 10 to the minus 5th per second. I hope that number looks familiar. Okay? So that's just the quickest crash course on what I do with natural logs and e to the x. And that's going to come in handy later on when we do pH. And pH is the log of something. And if I want to do the opposite of log, I do 10 to the, because log has a natural base 10. Natural log, I don't know if you know this, but ln of x is the same thing as saying log base e of x. All right? And if I have log of x, I'm saying log with a base 10 of x. That's assumed. And the opposite of log 10 is 10 to the x. Right? I take that base and I make it into an exponential equation. Same thing with log base e. The opposite of log base e is e to the x. So I'm hoping you could use that and remember that whenever we work with exponentials in the future, and this will help you for your kinetics unit right now.